Today, you guys, is an exciting day. We're going to look at 6-4, which is entitled nth roots. All right. Most of the time up to this point, we've been dealing with square root functions. So it's just a radical sign. There's no index on the outside. Turns out there's actually more than square roots that we can have in math. And that's kind of this first part we're going to look at. Remember, in math, each operation kind of has an inverse operation, so it can be undone. So like if we square something, we can square root it. If we add 2, we can subtract 2, right? So if we have a third power, we should be able to cube root it. If we have a fourth power, we should be able to fourth root it, okay? So this is kind of the first key concept of the day, all right? We have a radical sign. If there is an index out front, it's going to tell you what root it is. So if there's a 4 out front of your radical, it's going to be a fourth root. If there is not an index out there, we assume it's a radical or an index of 2. Okay. The radicand is the number underneath. And we'll just go into things a little bit more. And I'm actually going to kind of give you a sneak peek to 6-5 as well, because sometimes it's nice to think of problems this way as well. So 6-5 is going to be all about rational exponents. And I'm going to show you how the radicals and roots today are going to lead directly into the next lesson. Okay. So first things first, we have x cubed is 64. 4 times 4 times 4 is 64. So the cube root of 64 is 4. Hopefully that makes sense to you. Okay. Cube root of 64 is 4. If you don't have the fancy dancy calculators, all right, rational exponents are going to be super handy because you can also type in 64 and raise it to the 1/3 power. So a rational exponent is a fraction as an exponent, and the denominator of that fraction is going to match the index of your root. So we have 64 to the 1/3 is 4. We also have the cube root of 64 is 4. Okay. We do the same thing with the fourth power. 5 times 5 times 5 times 5 is 625. The 5 is the fourth root of 625, which is directly indicated here. Again, we could use rational exponents. So if I take 625 and I was to raise it to the 1/4 power, I would also get 5. Okay. I'm going to skip ahead to this last example. This is our general situation. So if I have a to some power, that equals b. A is the nth root of b, which can be indicated by this general notation. Again, n is the index of your root, b is the radicand, and a is your, obviously, solution in this case. If I was to write this in terms of rational exponents, again, the denominator of my power is the index of the root. All right. So that's kind of a lead in to 6-5, but just kind of show you how those relate to one another. Okay. I could even take this a step further for you. All right. And if we have b to the m and we're taking the nth root, this would be the same as b to the m over n. Okay. And the reason I show this to you now is sometimes it's easier to almost work with those rational exponents because we have a really good understanding of those powers. Like when we're multiplying two powers, we'd add exponents. When we have a power to a power, we multiply powers. So if we can get it in this rational exponent form, sometimes that's helpful for us. Okay. This next piece, just keep in mind, there are sometimes more roots that are possible. So typically when I ask you to evaluate the square root of 5, you just say 5, okay? If we were solving an equation and I said x squared equals 25, you would then give me both square roots of 25. And that's going to be this instance down here, okay? So just keep in mind as we evaluate, you want to give the principal square root. If you are solving, we should include both answers if it is an even root, okay? And that's kind of what this box goes through. If our root is even, there's one unique positive and one unique negative. If a is less than 0, all right, our roots are, there's no real roots. We have imaginary roots. And then the nth root of 0 is 0. All right. Keep in mind, if n is odd, there is one unique positive and 0 negative real roots. All right. If your a value is negative, all right, there is a negative real root. I mean, that would be like saying, what's the cube root of 8? Well, my answer is negative 2. It's not positive 2. It's negative 2. Negative 2 times negative 2 times negative 2 is a negative 8. And then the nth root of 0 is also 0. So if I have the cube root of 0, it still does equal 0. And that just kind of reiterates the idea that even powers do not have negative answers. Negative roots can have negative answers. All right. So as we go into things, today is just going to be a lot of simplifying. All right. And a lot of these problems are going to be really straightforward. So if I have positive or negative square root of 36 times x minus 10, well, you guessed it. What's the square root of 36? 6. What's the square root of x to the 10th? Well, hopefully you're thinking x to the 5th. A really easy way to kind of do that in your head is you take the power 10 and divide it by 2, right? You can use the index to help simplify that process, all right? In this case, I see I have a negative out front, so I'm going to leave a negative in the answer. All right. We have y minus 7 to the 16th, and we're taking the square root of that, which means I'm going to be left with y minus 7 to the, what's 16 divided by 2? 8. Good news, do not expand that, okay? There are going to be people on the quiz that take forever. I mean, this happens every year. I'm like, why are you taking so long on this quiz? And I get their quiz, and I see they've expanded every single one of these questions, okay? Do not expand it. We're working with powers, so I just want to see you simplifying with your exponents. You don't need to expand these questions, okay? Moving on to example 2, some different variations using absolute value. You're going to see a lot of this in your textbook, okay? We're not really concerned with this. On most of these, you're going to see us say assume variables are positive, okay? So as you look through the answer key, if you see absolute values, just ignore that piece, all right? That's not going to be something we focus on today, but just simplify, all right? Square root of 49 is 7. Square root of x to the 4th is x squared. Square root of x or y to the 6th is y to the 3rd, all right? In situations like this, if our variables were negative, we'd have to account for just our positive values, and you might see an answer like this in the textbook where our odd power is surrounded by absolute value bars. Again, that's not something we're worried about, okay? At this stage, we want to take the 4th root of 16. What times what times what times what is 16? You guessed it, 2. And then we have x minus 6 to the what power? 12 divided by 4 is 3. Again, you don't need to expand this. We're just focused on using those rules of exponents to simplify from here on out, okay? So again, if we have a power under our radical, we can divide that with the index. I'm going to show you a different way to kind of go through and think about problems here on this last one. And this may or may not help. If it doesn't help, then don't worry about it, okay? So kind of thinking about this, we have a 4th root, right? So sometimes you might think about breaking up things into groups of 4. So I know that 16 is 2 to the 4th. 2 times 16 is 32. I have x to the 4th, and x to the 4th is x to the 8th. I have y to the 4th, y to the 4th, and y to the 3rd is y to the 11th. And then I have z to the 4th, and z squared is z to the 6th. Again, this is just another way to do things and show you how to arrive at an answer. You don't need to expand it this way, but if your index is 4, like I said, sometimes it's helpful to break things up into groups of 4. All right, so the 4th root of 16 is 2, so I'm going to take a 2 out front. I can take 2 groups of x's out front. I can take 2 groups of y out front. I can take a group of z out front. I can even just put a 1 there if I want. If you notice, we have a 2, we have a y cubed and a z squared left. That is what would be left under your solution. Okay? So that would be one way to break it up. Another way, if you're mentally there, you could kind of do it this way. I know 32 is 16 times 2, so I'm going to take out a 2. I'm going to be left with a 2. 8, x to the 8th. I can take out 2 groups. I have no x's left. All right, 11 divided by 4 is going to be 2 with 3 left over. Got that one. Z to the 6th. 6 divided by 4 is 1, and I would have 2 left over. Okay. So notice you get the same answer both ways. Some of you, it might help to create this visual of groups of 4. Others, you might be able to use your number sense and do that division in your head to come up with those final answers. All right. Last problem we're going to look at today. You will have some word problems dealing with roots. Again, on your calculators, the cube root key is going to be under your math menu, which is on the left-hand side. Okay. First things first on this question, we're going to need the volume of a sphere. Does anyone remember volume of a sphere? Anyone? Mr. Shibusky would be so disappointed in you. All right. 4/3 pi r cubed is the volume of a sphere. All right. So in this case, the volume of a sphere is about 300 cubic inches. Determine the surface area. All right. So we have our volume formula set up. If you notice, we don't know R. We're trying to determine the surface area. Well, what's the surface area of a sphere? Again, Mr. Shibusky would be so disappointed with you guys. Surface area of a sphere is 4 pi r squared. So it looks like if I'm going to solve for surface area, I need my radius, which is why we go through the volume formula. All right, so what I'm going to do is I'm going to multiply both sides by 3/4. You wind up with 900 fourths equals pi r cubed. I would divide by pi. And then you need to take the cube root. So I need to take the cube root of 900 divided by 4 pi, which equals r, which in this case is about 4.15. Do not use that number in your answer, okay? That's what's called rounding error. You want to use this exact number in your problem, all right? Otherwise, you get what is called, again, rounding error. So we're going to use this number exactly. You probably can pull it from your calculator directly, all right? But we're going to take that number, whatever it is, we're going to square it and multiply it by 4 pi, and you should get 216.7 square inches. All right. Remember on those problems, or just any problems in math, if you use a rounded answer to get another answer, you have what's called rounding error, okay? You want to use exact answers in problems throughout. You never want to round until your very last step, okay? So kind of keep that in mind. Use that exact answer. This is going to be especially true when we go through or go into trig, which is chapter 12, okay? But make sure you use that answer consistently throughout, and then you can round at the very end to give your answer, all right? Lessons on the bottom, remember EOE means every other even. If you have any questions or concerns, please let me know. Otherwise, best of luck. We'll spend time reviewing before the quiz. And then we're getting towards the end of the quarter here. So try to scrounge up the last few points and enjoy the last couple days of quarter